In the previous video, we used UV manipulation to distort the main texture of the fire shader. Now we're mostly going to work on the depth fade and dissolve. In the scene gizmo, click the tiny cube to toggle between orthographic versus perspective. And now I want to adjust the position of it better in relation to the logs. Now we want to fix the pivot of the particles because the way the stretched billboard alters the pivot doesn't make sense for our situation. And it will look especially bad when we start using the scale over lifetime module. You can check Visualize Pivot, which shows you a tiny green cross at the pivot of each of the particles that are playing. In our case, we want to set the pivot in the y-axis to be 0.5. This value is proportionate to the size of the quad, so you could potentially export a giant custom quad from Blender and still use 0.5. Now let's move down the entire game object of the particle system. Let's turn on the size over lifetime module and make the fire scale up. To me, it feels like the fire should die off while still having the same energy. I'm also temporarily setting it to emit just one particle per second so I can analyze each particle better. You can click this default curve, then click this point and drag it up to about 0.5. These values multiply with the start size values of the particle. The leftmost side of the curve is the particle at the start of its lifetime, and the rightmost side is the particle at the end of its lifetime. Now the flames look slightly too small, so let's increase the start size values. And set the count back to 5.5, then turn off Selection Outline and turn off Visualize Pivot. Now let's fix the clipping of the fire against the logs. If I pause the particle system, you can see it more clearly. We're going to use a technique called depth fade to fade out the parts of the fire that are closer to opaque objects, such as these logs. I'm going to start by creating a subgraph because this is a functionality that's often used in a variety of different shaders. A subgraph is basically a bunch of shader graph nodes packaged into one node. Give it a name and then double click on it to open it. I'm going to right click and create a scene depth node and set it to I. Then right click and create a screen position node set to raw. Subtract the fourth component of the screen position from the scene depth. I'm going to explain what these nodes do in just a minute. I'm going to minimize these except for the screen position because it helps me remember what's happening at a glance. Now let's create a property. This will be the input slot that our subgraph ends up having. This will control the depth fade effect. Plug it into the output and let's change the output to be a float. And change its name too, so it's not misleading. Let's give the input slot of the subgraph a default value of 1. Now this isn't necessary, but you might find it helpful to leave some notes in your subgraph. You can pause the video here to read them if you want. I'm also going to show you with visuals the basic idea of what happens in just a minute. Here is one more note. To demonstrate the basic idea of how the depth fade works, I'm going to create a new shader and material and assign it to a plane mesh. drag the material into the object to assign it. Now let's edit the shader. We could add the subgraph here that we just made, but I think it's better to have all the nodes visible for this explanation. So I'm just going to copy and paste them here. I created a float property called depth fade multiplier and set it to a default of 1 in the graph inspector. Plug the scene depth node into the base color. The scene depth node has an output type of float and tells us the distance to the opaque objects in the scene. But the base color node expects a vector 3 to use as RGB values. So it copies the float value to make a vector 3, which causes a grayscale output. For example, if the float is 0.7, it will give an RGB of 0.7, 0.7, 0.7, which is light gray. Values beyond 1, beyond white, cause more and more bloom if you have bloom turned on in your scene, which I do in this case, as you can see. When you get close to the plane mesh, the objects that are less than 1 unit of distance from the camera will show up as a shade of gray. The grass that we can see through the plane mesh may not look like gray, but that's kind of an optical illusion, so let me cover up the green so you can tell. Now let's plug in the screen position node. The plane mesh will have parts that are darker where it's closer to the camera because there are less units of distance away from us. Less units means smaller values, which means darker colors. For instance, this point is light gray, so I estimate it's about 0.3 units away from the camera, meaning its RGB values are 0.3, 0.3, 0.3. And these would be a couple of my other estimates. If we move too far away, we won't notice which bits are darker because it's all in the bloom range. Now let's plug in the depth fade value, which is the distance from the plane mesh to the objects behind it. And this time, the camera distance won't matter. The objects that are less than 1 unit away from the plane will show up as a shade between white and black. One way we can adjust the depth fade is to multiply the values. Now let's use these values for the opacity instead of color, and let's do it in the fire shader, using our depth fade subgraph. The darker values will make the fire particles be more faded, and the lighter values will make it more opaque, because 0 alpha is fully transparent and 1 is fully opaque. Let's create a float property so we can plug it into the depth fade multiplier slot. Save it and let's see what problems we get. You get problems when you have alpha values that are not within 0 and 1. If we set depth fade multiplier to 0, that means we're multiplying the values by 0 before plugging it into the alpha block node. That's why it becomes invisible. And if we increase this to a high number, then most of the alpha values go beyond 1, which causes these weird, unexpected colors. So let's go to our fire shader and double click on the subgraph to open its window. And let's use a saturate node to keep the values between 0 and 1. You can right click here or drag a wire from the multiply node and search for saturate. Click on the top left to save your changes. Now the value of depth fade multiplier never causes the alpha to go outside of 0 and 1. It seems like I left the point light on from the original campfire I made, so let me turn it off. In this shader graph, I'm going to group things together to make it tidy and easy to understand at a glance. Now let's make the fire dissolve away instead of just fading out. Let's start by adding a noise texture. Create a sample texture 2D node, then add a category for the properties related to the dissolve, just to keep it tidy. Select the category, then click to create a texture 2D property. Tick here so you can adjust the tiling and offset in the material instance. This default mechanism is fine. We don't need to keep it centered like the fire silhouette. Click here to choose the default noise texture for the TX dissolve property. Now let's create a smooth step node to basically adjust the whites versus blacks of the texture. And create a vector 2 property to control the smooth step. But first, I'm going to quickly explain what the step node does. If the input is less than the value of edge, then it converts it to 0, which is black. If the input is equal to or greater than edge, it converts it to 1, which is white. For instance, this pixel in the texture is pretty dark, so we can estimate it's about 0.2, and that's reflected in how the step node processes it. The smooth step node does the same thing, but it also allows you to adjust the smoothness of the transition between white and black. The go-to setup that I learned and almost always use for dissolving is like this. The first component of the vector 2 controls the step, and the second controls the smoothness. You can double-click on a wire to create a reroute node, which is just for tidying up the look of the shader graph. I'm going to give dissolve smooth step these values. Now I'm going to delete the preview node and have a subtract node. So the lighter parts of the dissolve noise texture will cause more subtraction and therefore more transparent fire, whereas the darker parts will cause more opaqueness, if that's even a word. You could use a multiply node instead of subtract to get similar results, but I prefer using subtract in this situation. Now let's multiply this with the other chain of values that affect the alpha. Remember, if you're getting confused about why we're multiplying, you can pick a point, estimate its value, and then manually calculate the simple maths that happens, as I've shown previously. Now let's save and look at the results. It's invisible because Unity doesn't give it the default noise texture that we set, unless we reset this material instance. And when the texture is blank, the value Unity uses is as if the texture were 100% white. So the alpha is subtracted by white, which is a value of 1, making the fire invisible. Now let's pick our noise texture again. Let's pause the particle system and adjust playback time so we just see one particle. That way we can see better the dissolve effect. And remember, this scrolling is because the shader itself has the noise texture animating. It's not the particle system that's causing this. Alright, so we want our dissolve to do something like this, but we're going to control this animation with a curve in the particle system. I'm copying these values from my finished fire. It doesn't look good yet because we also need the custom data module to also control the dissolve. By the way, I could use the alpha value from the vertex color node instead of this custom data approach, but I want to be able to dissolve independently in addition to fading out. Just a quick explanation of vertex streams. We have already been using these. Here's a simple shader with the vertex color node connected to base color. I made a material instance from it and applied it to this particle system emitting cubes. Currently, we can set its color in the particle system because of the vertex color node in the shader graph. If you tick the box for custom vertex streams, you can customize the vertex streams. For example, we can delete the color vertex stream, so now the vertex color node can no longer read the color information from our particle system. See how the start color isn't changing the cubes anymore? By the way, you can hover over it to see the tooltip that we are passing information from the particle system to the shader. Now back to our fire. Turn on custom data and set it to a vector with just one component. You can think of this vector as a float or just a regular number. Also have custom vertex streams turned on and add custom1.x. This setup makes it so that our particle system is sending information to the third component of UV0 in the shader graph. Let's edit the shader to read that information and do something with it. Remember that the UV node outputs a vector 4, and we're already using the first two components for the U and V coordinates of the textures. But now let's use the third. Remember, you can use the swizzle node set to Z or the split node. Let's plug this in directly into the base color so you can see the values. The way Unity is, it may be confusing that we are using the third component of the UV node if we selected custom1.x. We might instead expect there to be custom1.z, but the alternative setups are worse in my opinion, so I'm just showing you this one. Okay, so remember, 0 results in black, 1 is white, and there's everything in between. Now let's reconnect the nodes we were using for color and alpha. And let's use the custom data value as an extra way to control the smooth step, so we can animate it like other values in the particle system, such as size over lifetime. I like to leave in the smooth step property so I can still control it without needing custom data, in case I use this material in another situation. I think the dissolve looks fine if we leave the smoothness as it is and only adjust the step to make it disappear. One way to do this is to separate out the X and Y components of dissolve smooth step, so we can add to the X, then combine them back together. Let me tidy this up. Then save and go back to the particle system. Now we can change the dissolve inside the custom data module. After experimenting a bit, the values I was happy with were these for the material. Now for the dissolve curve inside custom data. You can click on these curve templates below as a starting point. Select a point and then press enter to type in the time and value. The curve editor started being glitchy, not wanting to go below 0, so I ended up deselecting it and selecting it again, just to fix that. I actually decided to use a 1- node for this because I want the higher values in the curve to cause more dissolve. Now, when we increase the step value inside custom data, it'll make this more white, which means it causes more subtraction from the opacity. I'm going to pause the particle system to edit the bloom multiplier property. Then I'll quickly decrease the rate over time to see what each particle looks like by itself. This looks good to me. Now I want to make it so the distortion in each particle has a random scroll speed between 0.3 and 0.6 instead of them all being the same speed. It's not that noticeable, but it will give it a more natural look that I think looks nicer. Again, I'm going to use the custom data module, so this time I'm going to hook up the fourth value of UV0. I'll just multiply it with whatever the speed is in the Vector2 property called Distortion Speed UV. I like making sticky notes to easily identify when I'm using custom data. Let's switch from custom1.x to custom1.xy so we can also send information from the particle system to the shader via that fourth component of the UV node. Change the number of components to 2, and you can also rename the components. It might help you to remember better how custom data works if your names actually include the X and Y, or maybe Z and W, because those are the components we use from the UV node. If we pause the particle system and have our distortion speed multiplier set to 0, then the speed will be 0. Remember, these are the values we are multiplying with. Now let's set this to be a random number with the minimum possible value being 0.3 and maximum 0.6. Again, it's helpful to look at the effect paused, or just look at one particle at a time to understand better how the whole effect comes together. And try pushing things further than you think they should be, like making the distortion scroll too fast, so you then know how much you need to tone it down. In the end, I just settled with the range of 0.3 and 0.6. Now let's edit the shader so the bits that are more dissolved are also more red, like this. This is kind of subtle, so here's a more exaggerated example so you know what I mean. The reason the color property is green but is causing a red effect is because we're subtracting green from the regular orange of the fire, causing red. If that's too confusing, I'll show you a more intuitive approach later that gives you a similar look for the fire. But now I'm going to create a smooth step subgraph because I pretty much always follow that smooth step setup that I showed earlier, and this makes the shader more compact. Double click to open it. The input float will usually be a black and white texture for me. Remember, you can name these whatever makes sense to you. It's the property type that matters. I want the output to be a float type, so I'll change the name to prevent any confusion and, more importantly, change the type. You don't need the subgraph, but I personally find it very useful. Now you can use that subgraph here for both the main texture and the dissolve texture. Now create the vector 2 that will control the smooth step. Maybe a better name would have been smooth step edge color. So just select the output node and set preview to be 2D. Now we can adjust the smooth step and it resembles our fire texture instead of being projected onto a sphere. Let's multiply this with a color, which will end up being that green that I showed. Honestly, I couldn't think of a good name for this color property. Maybe color subtraction edges would have been a better name. I'll make some room again. And let's subtract the fire color by this blue color. Then save the shader so the changes show up in the material. I'm going to pause the particle system and unwind the playback time so there are only 2 particles spawned so I can see the effects of this color subtraction. I'm also going to set the distortion multiplier to 0 so I can see the edge colors better, and I'll change the smoothness value to 0.3. In hindsight, using the main fire texture for this color subtraction doesn't get me the results I really want. The texture that makes the most noticeable difference for the faded out colors is just the dissolve texture. Let's include that one now. I'm just going to open up some space. I want the colors of the faded edges to be affected by the smooth step that we already have for the transparency. But I also want to control it up here. So I'm going to drag out a wire and multiply with the main fire texture like this. Then make some room and connect it to the smooth step subgraph. I feel like I should tidy up a bit more. Then save the shader graph. Now let's see how having the dissolve texture affect the colors makes much more of a difference. I'm going to zero out the scrolling. Actually, I'm just dividing it by 1000 so I'll know later what the value should be. And I'll have just one particle so that we can see the results better. If I subtract it by black, it means it won't affect the color because it's a subtraction by 0. Now let's add the movement back. If this subtraction functionality was too counterintuitive for you, you can use a node called lerp, which is short for linear interpolation. Basically, values of 0 that go into the T slot will make the lerp node pick from slot A, which in this case is the color red, and values of 1 will cause it to pick slot B, and values in between will give a mix of the two colors. Make sure T doesn't have any values greater than 1 or less than 0, unless you understand lerp well and you're doing it intentionally. That's the end of this video. In the next one, we're going to finish off this campfire, including quickly going over the other particle systems, which use basically the same functionalities. And remember, when you're making VFX, no matter what the situation, it's crucial that you always remember